So we're in Chapter 19.4, Inferences about a Population, and we're going to continue working with hypothesis testing about the proportion. Let's look at another example about math skills. In an August 2003 survey, 56% of employed adults in the U.S. reported that basic mathematical skills were critical or very important to my job. The supervisor of the job placement office at GMU thinks that this percentage has increased due to the increased use of technology in the workplace. He takes a random sample of 480 employed adults and finds that 297 of them respond with the same answer. Is there sufficient evidence to conclude that the percentage of employed adults answering affirmatively has increased? Test at the 0.05 level of significance. Well, the first thing here is, do all the assumptions met? And they are. Our number of successes and failures are all greater than 15 for sure. So now we have to think about, what's my null and alternative? Well, the null is that we believe that 56% of employed adults in the U.S. reported basic math skills were critical or very important to their job. Now the alternative is the supervisor at the job placement office at GMU thinks it's increased. So it's a right-tailed test that P is greater than 0.56. So now we're ready to write up our null and alternative and conduct our hypothesis test. So our null and alternative hypothesis is, the null hypothesis says that P equals 0.56. My alternative is P greater than 0.56. And our alpha here is at a 0.05 significance level. When we do our commands in Minitab, PWN, we have to put in our N and our number of successes. So it would be 480, 297 believed that math skills were important. We're testing our value in the null hypothesis is 0.56. The alternative is 1 because we're in a right-tailed test, and use Z. In other words, let's do the normal approximation. When we do this, we get our test statistic of 2.56 and a p-value of 0.005. Well, let's see how we would answer. Since the p-value is 0.005, it's less than our alpha of 0.05, so we reject the null hypothesis. So our conclusion would be written as such. At a 0.05 level of significance, there is sufficient evidence to conclude that the percentage of employed adults answering affirmatively has increased. Now let's look what happens if we're given raw data. In the last presidential election, a national survey company claimed that the fraction of all registered voters who voted for the Republican candidate was different from 1/2. A random sample of 100 registered voters was taken, and all the responses were recorded in the data set provided below. Now, Y stands for the Republican candidate. At a 0.05 significance level, test that claim, the company's claim. Now, this is in a data file in Minitab, and what we're going to do is we're going to see the commands and the answers that would happen. But let's think about our null and alternative hypothesis. The null hypothesis is going to be that P equals 0.5 This company claims that it differs from 1/2, so this is going to be a two-tailed test. So our data was in column 1 in Minitab. We say PWN C1, test 0.5 because that's the value in our null hypothesis distribution. We let it know that it's a two-tailed test by saying alternative 0, and then also let Minitab know that we're doing the normal approximation, so we say use Z. When we get our Z and our P value, we see that our Z value, our test statistic, is 0.60, and the P value is 0.55. So that means our sample tells us that we're going to make a mistake 55% of the time, like do a type 1 error 55% of the time, which is not good. Don't want to do that. So how would we answer this? Since the p-value is 0.54 and it is greater than 0.05, we do not reject the null hypothesis. Therefore, we would write our conclusion as such. At a 0.05 level of significance, there is insufficient evidence to conclude that the fraction of all registered voters who voted for the Republican candidate was different from 1/2. Well, this concludes Chapter 19. We will begin in Chapter 20, and that will be 2 sample proportion problems where we two different samples and their proportions. So thank you for listening. See you next time.